Okay, question 4 of chapter 2 um, for Introduction to Statistical Learning. So this wants us to give 3 examples that we come up with on our own for each of applications for classification, applications for regression, and applications for cluster analysis. So I'm just going to provide one because obviously everybody's answers will vary quite radically. So hopefully you can identify when each of these types of analyses is required. So these are my answers for categorization. I said, okay, well, maybe self-driving cars, needing to discern human pedestrians from non-human objects. So here the response obviously is the judgment between human and non-human things. And the predictor data may be the shape and movement of objects as detected by cameras on the vehicle. This is whether, we're also asked whether it's prediction or inference. And here, even though this is not future tense, I see the object and I either say it's human or not human. So there's no future tense. This is still prediction because I don't care how the different inputs bear on the judgment of it being human or not human. I just want to make sure that it predicts correctly or assesses correctly human or not human. Okay, so for regression, what I said was projecting individual incomes. So obviously the response is somebody's future income, and predictor variables may be things like their age, how much their parents make, things like this, career. And so this is regression. It's regression because we want a specific value for the projected income or a range of values. So we can use this regression for prediction, right? We can say, well, here's Johnny, and he's this old, and his parents make this much, and so on and so forth. This is what I predict him to make in the future. But it's also inference because, for instance, I might want to know how I can increase my future earning potential, and so I can look at the regression, and I can notice which variables seem to be important in increasing earnings, and so I can try in my own life to change those things, right? I might go acquire more education or a specific type of education or something like that. Okay. Now finally, we need to describe some applications for cluster analysis. And so what I said was categorizing brain states. So this is a little bit of a weird idea, or a weird term, I should say. But brain states. So your brain is constantly doing all sorts of things that can be detected electrically with something called an EEG, and presumably different brain states have their own signature of EEG. So the reason that this might be good for cluster analysis is I might not have a clear sense of these different categories of these different brain states, these different clusters, right? But I have EEG data, and I can apply a cluster analysis, and I'm telling the algorithm, go in here and with the data distinguish things, periods of time that look similar to other periods of time, and we'll call those brain states. Okay, so those are my answers.